So Zed just dropped a new AI editing feature, and I'm seriously curious to see how it works because it's supposed to be pretty cool. Now, it's an open source repo, but let's be real, open source at this size and scale can be a total black box. Sometimes it's a week-long project to just unpack a repo and understand the files just to get how some specific thing works. But that's all changed. Today we're going to clone it, and I'm going to show you how we can use AI to get a handle on this thing in like 10 minutes in real time. So what I'm doing here is I'm using Tree to just get a quick idea of all the files that are in the repo. There's a lot. And I'm passing that into Gemini to get a quick winnowing down of what files might be relevant to the specific thing that I'm looking for, which is just, I'm trying to understand exactly where the core logic would be for ZAI. Once we have it, normally we'd be stuck reading just this large set of files that all interconnect ourselves. But we can use Mandark, which I'm going to link below, with Gemini Flash through Msty, which is just my interface. It's great. I'll link that below as well, to help us figure out which files are even really worth our time. And so what we're doing here is just telling Flash that this is the breakdown of all the files. And we've also added a little switch to Tree to limit it to two levels so that we only get the top two levels of what's happening. And we're looking for the core logic. Now, Gemini's already come back to us and said, hey, these are the files. We've turned it into a quick string of things that we can paste into Mandark. And you can quickly see me just copy that over to clipboard. Now, the interesting thing here is Zed is actually written in Rust, which makes it really, really fast. But my Rust skills are pretty rusty. So all of this helps me understand what's happening. Like, I sort of get the concept of crates. I've written a little bit of Rust, but that's really all of it. And I'm trying to understand, okay, what are the cool things they're doing here? How does it really work? So what we're doing now is just taking all of this information and then feeding that through Mandark into Gemini, and then going, okay, give me an initial idea of which files are involved, give me references. And I'm using that to effectively cut down the number of tokens. You can activate Mandark directly from the command line, and all it does is take the code, sort of line tag it, extract the right parts of that code, maybe get rid of the import statements, and then copy it to the clipboard. So what we have here already, and we'll look at it later, is quite a few tokens. Depending on how big your project is, this can be massive. This is about 500,000. In some cases, I've seen up to 2 to 3 million tokens. And we can still reasonably fit all of this into a context window. But as we start asking more complex questions and asking for more complex output, we want to whittle that down because LLM performance goes down the more you stuff the context. Now, here we're actually using the LLM to make the LLM's life easier. We're using it to narrow down to specific files that we care about. And we're taking those specific files, passing them back through Mandark to get maybe 250,000 tokens. And that's actually pretty easy. Especially with Msty, you can just branch a chat off, start just a little sub chat, and then quickly get the list of files that we want to use. So once you copy those through, and if I just look at the token count for those, half, right? Significantly better. Faster, cheaper if you're using the API, and just way better to ask more complex questions based on that. Now, what we're asking for is trying to understand exactly how different parts of this work, right? And if you ask for it, you'll start getting examples from Gemini here, which is still one of the best long context LLMs that we've got. So we've got specific modules and objects internally that are connecting to each other. I primarily care about the AI bits here. I care about the prompts, I care about extraction, I care if they're doing anything really interesting with editing code, sort of fill in the middle, or new techniques that are happening. So I might ask a few specific questions, but I'll also ask for a markdown doc. Oftentimes that gives you just a very clean document that you can start putting together, and much easier to read and communicate over. So in this particular case, once I've got a lot of my specific questions in, and the questions are really, really helpful, it's always good to add questions based on your understanding because it works a lot better the more involved you are in the process. You can also pull information out of the LLM by asking for what might be confusing it. But in this case, this is maybe the fifth code base that I'm looking at for the specific task. So I know what I'm looking for, so I'm asking specific questions. Now, what's really, really interesting here is that code used to be this inscrutable thing, right? Because beyond a certain size of repo, open source meant that even though you had access to the code, unless you were specifically well versed in what that program was doing or the language it was written in, might as well be Greek. You can barely ever get a sense of what's going on. And that's caused a large number of problems, including for developers of open source projects themselves, like myself, which is that code can get increasingly complex to the point where you can slip in problems, you can slip things into patches, and the original guiding principle of being able to share logic and understand how people do things gets harder and harder at larger and larger code bases. So then we kind of just started implementing abstractions and then dependencies where you just get the entire project, like almost like modern playwrights do, warts and all. Not just the banana, but the gorilla holding the banana and everything else. Like in this case, if I wanted to use ZAI specific methods, one method would have been to use that repo as a submodule and pull out their specific files. But in this case, I can build an understanding of how they do something, and using AI, I can just translate it into a clean kernel implementation of just the bits that I care about, right? So it's a really great translation engine. So here it's trying to answer my questions directly, one after the other. Markdown formatting understandably breaks a little bit when you ask for prompts inside of Markdown, because the prompts themselves go inside Markdown blocks, and then the prompts have Markdown blocks with other stuff inside of it, but that's okay. We're starting to build an understanding. Now, it's okay if you're skimming this, because in some cases I am myself. My goal here is to come up with a really clean doc, so all my attention is focused on what could make that better, and then I read the doc. But what we are effectively doing is building that logic kernel without necessarily needing to use the code directly. But this begs the question, at least to me, of how open source licenses affect something like this. I don't think they directly do, but I think they should, because what we're doing is borrowing and using the code as inspiration. Just previously, it took an entire human to read and understand code and sort of parse it through. And that throttling of needing a smart enough human to do it meant that it didn't happen often enough for that to be a clear enough problem, which is where like clean room things, IMP, come in. But with AI, that really has changed quite a bit. So now I'm asking for a bit more information, specifically things I care about. But the interesting bit is I'm asking it to use TypeScript and translate to TypeScript for didactic examples, which is working great. Like I understand TypeScript like I understand English at this point. So this is very, very easy for me to read. You could do Python, you could even do English, pseudocode, Prolog, whatever you wanted to. And it's doing that real-time translation, within reason, with examples to tell me how it's actually doing different parts of code editing. Now, I can ask more specific questions, as you'll see later, about things like, hey, are they using the syntax tree? Are they using specific techniques? But I may not always need to. What I really like about Gemini is it gives you very clear answers in a lot of cases. If you ask a question, often you'll get a direct answer with an explanation and possibly things that you might have missed. Really, really smart model. Msty makes it really easy to use almost any model, but these days I just find myself going back to the Flash model. And okay, so we've got most of the key things just pulled out. There's probably even a prompt library in there. And these are all things that you need to go in and verify yourself. But all the things that I really care about, like parsing structured outputs, the specific instructions, there's almost an edit library in there. And it looks like they're using JSON structured outputs to actually connect to the edits. They're using Claude style, repeat the line you want to replace format. They're also using XML a little bit. So that's really good to see. These are always things that you should go in and verify yourself. But for quickly understanding large open source projects and just answering the curiosity or sometimes professionally relevant question of how someone's doing something, that just got orders of magnitude easier. Right? It would have taken me 4 to 5 days in some of these cases of just work to make sure that I had an exhaustive understanding of something before I could then begin translating it to a portable format that conveyed that understanding of how something was happening inside of a repository. Small sidebar here is Gemini is also one of the best models I've seen for continuing where it left off. This has a lot more to do with prompt adherence and instruction tuning, but it's always nice to see when models can just do that straight up. It's always very appreciated. But I wish we'd bring prefill back, because prefill was always the absolute best way to make sure that a model continued where it left off, or any sort of structure adherence or format adherence. Prefill makes it so much easier. But what we're doing now is turning everything we've done into notes. We need a write-up that sort of concretizes everything we know so that we can communicate it to someone else. Like I'll link it below. I'll link my full study below across multiple code bases on what the techniques are. And maybe I'll do a video on it later, or I'll write that up. But what happened there is I would build individual documents like this and almost build a super prompt of those documents with my own edits and sort of notes, with an additional set of prompts, an additional set of questions, all of the things that occurred to me or that came from LLMs, and then combine them into more of a meta study. Again, it prevents that exponential rise in time as you try and cover more things. But here, I'm going to start copying a lot of the work that we did into the Notion page. And what sometimes I'll do, which I'm skipping in this case for time, is to pass in the repos with the commit link and ask to turn everything into a permalink, right? That makes it far, far easier to navigate. But here, I'm generally just looking for anything that needs immediate fixing. So far, everything looks pretty good. I might look for specific, say, syntactic sugar changes. The TypeScript markdown formatting has broken in a few places, and that might need to get fixed. But that was mostly it, right? Now, in this case, the review of editing with LLMs is all the work that happened before, and that's across, say, Void, Tabby, OpenDevin, Cloud Engineer, even Mandark itself, into how edits are managed across LLMs. Editing, I think, is still very much an open problem, and that doing it reliably for large amounts of documents is a very, very valuable problem to solve, but we don't necessarily know how to do it. This is something that I might end up studying myself in terms of finding out what the most appropriate, most effective ways to do it is, and if that division exists across models. But this is the beginning of that. This is almost the prior art research there. So we've copied in the code understanding. We'll also copy in, say, maybe the specific files that were involved. That makes it so easier for anyone else to follow the path that we did with Mandark or something else. And also, if we made a mistake, understand where that mistake came from. Once we're done with that, we're going to start copying in the more specific TypeScript examples or TypeScript translations of Zed's internal logic, right? But what's cool here is, are we taking the underlying feature from Zed? Sort of. None of this is production ready. None of this is at a point where you can just deploy it because the number of, patchwork of band-aids that you need to make something production ready requires real production use. And that's something that the Zed team knows. And it's very hard to take anyway. What this does is get you the logic. It gives you a starting point, right? And if someone is doing something really clever and new, often this should give you a reasonable working prototype implementation with the core idea so you can build on top. Same as the spirit of open source, right? Now, I'm just pasting that in. I'm just clearing up a few of the formatting things. This is also a great didactic tool. LLMs, I think, are one of the best things, if not the best thing in my lifetime to have happened to adult learning. Almost like a babble fish for different kinds of information because they know just enough to help you learn. Maybe not teach you directly, but help you learn and sort of smooth over a lot of the things that might have taken reading 15 different books and talking to 20 people just to get that tiny connecting piece of information that helps you understand something better. So this has just been genuinely great. Now, let's say you want to understand, how VS Code is so fast for being an Electron app. This is not a method for you to steal that or sort of take that from VS Code. But if you see a new feature or you see something specific where you go, well, how are they doing in-memory transport or something else, it makes it significantly easier. And it's changed the way I interact with open source and code. It's actually made a lot of code. We used to say that self-documenting, right? So here we're just doing a little bit of cleanup. Just make sure that it's easy to paste in and sort of looking at those different pieces, getting rid of a little bit of the summary bits. And there we go, tiny bit more, but in the span of, let's say, 14 minutes and 13 seconds, we have taken a reasonable, grok at the understanding of Zed's new AI feature and built a document that covers our understanding. Right, in between, I'm also reading these things. And so it's also really useful for me to learn and ask questions and go back and forth. I also now have a bunch of chats that are preloaded with that context. If I want granular understanding, I'll go to one that has the files themselves. If I want something a bit faster, broader scale, I might paste the document that we've generated back in. And so I can now, anytime I have a question, go back to those chats and just ask direct questions about how something works. Now, it's good to double check a lot of what's happening here. Nothing beats, a deep level understanding that you built yourself. But given how much information comes at us and how fast spaces move, institutionally, organizationally, like personally, and also just for sharing, this to me is a good proxy, right? A better proxy in a lot of cases than the original code.